Welcome everyone to this new series of virtual seminars organized by the International Society for the Study of Early Medieval England. We're organizing these virtual seminars to showcase all of the exciting research that's going on within our field, ranging from comparative linguistics to manuscript study to Old English poetry to archaeology. And today we're very excited to be teaming up with a very exciting project called Ansund, which is a project led by Elisabetta Magnanti of the University of Vienna and Mark Faulkner of Trinity College, Dublin. Elisabetta Magnanti is a university assistant at the University of Vienna. She has recently submitted her PhD and she will soon have a viva, so good luck. And Mark Faulkner is the Usher Assistant Professor in Medieval Literature at Trinity College, Dublin. And they're going to tell us something about their fascinating and exciting new project that uses AI and machine learning to develop a new exhaustive open access corpus of Old English. Mark and Elisabetta, take it away.
Thank you. Thank you everyone for coming. So you will probably be familiar with some of the resources in terms of corpora that already exist for Old English. Principally the Dictionary of Old English corpus, which contains at least one copy of every Old English text, so about 3 million words in total. Has a subscription-based financial model, which is actually very important, I think, to the field that is sustained, because we all want the Dictionary of Old English to be finished, and it's great to see Stephen Pelly in the audience today. The current 2009 version is only accessible online and has quite limited search functionality. It's based on published editions. The texts contain emendations, albeit that they're marked in angled brackets if they do contain them. And copyright resides in the underlying editions, so it's impossible or infeasible at the moment to publish any data sets derived from the Dictionary of Old English. So if you want to do some corpus work with the dictionary and publish your results, you really can't, as far as I understand it. The coverage is also not comprehensive in that it does only have at least one copy of every Old English text, so not every copy of De Initio Creaturae by Elfrich, for instance, is represented separately there. There's no lexical, part of speech, or syntactic tagging either. So there are some ways in which we could improve the corpus resources we have here. Maybe less familiar to you is the Manchester 11th Century Spellings project, which was run by Don Scragg and launched in 2004 and has alas been offline since 2009. This comprises a database of 165 manuscripts and documents containing about 1,800 texts, and they transcribed about 1,000 of those, collectively 1.8 million words. And the big difference to the Dictionary of Old English corpus is that this does contain multiple copies of individual works. So there's 9 different copies of Elfrich's De Initio Creaturae in there. But even between the Manchester project and the Dictionary of Old English corpus, there are still gaps in the coverage of these corpora. My own initial attempt to fill this was a small corpus called Toxic, Trinity Old English from the 12th century, which looked at some underrepresented manuscripts in the Dictionary of Old English corpus, like Cotton Faustina A9, which is just represented by 2 of its 38 items in the corpus. And this was run between 2016 and 2019. And at this stage, the logical choice to produce such a corpus was to get some research assistants to transcribe the manuscripts. And so it's very exciting that even in the relatively short period since this, we're talking 6 to 8 years, a new opportunity has opened up. There's a new way to build corpora now, and that's what we're going to tell you about today. And it's what the Ansund project is developed to do. So it takes its name from the Old English adjective Ansund, meaning healthy or complete in body. And here we have a bit of a translingual pun. So we understand body as Latin corpus. So we're trying to make Old English healthy and complete in its corpora. And the aim is to build a new exhaustive open access corpus of Old English using handwritten text recognition, which we'll explain to you in a bit. Our current funding is about just over 22,000 euros from various internal Trinity schemes and also some Erasmus Plus money. And what we've been doing with that is piloting the approach. And we hope, well, we will show you, I think, that we have proven that the approach we're taking works, and then it just becomes a matter of funding the full rollout of this project. Our objectives are to develop new transcription conventions that maximally record meaningful orthographic and graphemic variation. And I think this is one thing that our work is extremely novel in regard to, even in the field of HTR, that we're looking to record all of the different graphemes used to write Old English, to build a research team that can transcribe training data, and we'll talk a little bit about that in a moment, and then correct that output of that training data, and eventually develop a funding model where we can bring this corpus to fruition. So that is the background. Ellie is now going to give you a brief 5-minute introduction to handwritten text recognition and how it works.
Thank you. Can you hear me properly? Because I was having a little bit of problems with connection. It was being a little bit unstable.
Yeah, I can hear you.
Okay, good. Thank you. So machine learning, good, thank you. Machine learning, what is this? Well, machine learning is a branch of artificial intelligence where basically systems learn from data how to make decisions and how to predict those decisions. In what we call supervised machine learning, we have models trained on a specific labeled dataset. This means that the model learns to map inputs on outputs based on given examples, and can later predict outcomes for data that has never seen before, so for new data. Next, please. Next.
It's changed for me. I'm not sure if it's changed for you.
Yep, I have. So computer vision is, of course, one of the most well-known fields of machine learning, and it's the sort of technology we all deal with on a daily basis in applications such as facial recognition or image classification. It essentially enables machines to interpret and understand visual information from images or videos, if you want. And so through algorithms and models, the machine learn how to detect objects, identify patterns in large-scale visual data, and most importantly, how to make sense of this. Next. And OCR is a technology within computer vision that focuses on recognizing and extracting text from printed sources, whether this is, scanned documents, PDFs, photos, and once it has extracted this, it can convert it into a machine-readable format, thus making it searchable and editable. And this is the sort of technology that lies behind the early English books online database, thanks to which I think hundreds of thousands of books from the mid-15th to the 18th century have been made available online. Next. And HTR, if we want, is the equivalent of OCR for handwritten text. And as such, of course, it requires more advanced techniques to handle the variability and complexity of human writing. Next. And there are currently many tools and software who are capable of this, one of which, and the one that we are currently using, is Transcribus. Next. And the other one is Kraken, which is the engine behind, next slide please, behind the software eScriptorium developed in France. So those are, I would say, the main software currently available for handling HTR online, specifically for working with manuscripts. Next.
It's me again.
Yep, so sorry, as I said, I can't see the slide.
The most novel parts of our project is that we're trying to represent the graphemic variation used to write Old English as fully as possible. And so we're all kind of familiar with students trying to engage with Old English for the first time and wondering how do they represent a thorn, and often transcribe it as P and making us want to bang our heads against the desk. But then we teach them that they can use symbol in Microsoft Word and that they can find a thorn there, and then that means they can write that. But as we then know as researchers, when we're maybe editing a text and we've got a thorn with a bar through it, we have a decision whether we expand that as that with an A, or thet with an E, or even with an ash. So actually, optimally, maybe we should leave that as thorn with a bar, particularly if we're interested in orthographic kinds of questions. And the problems only multiply from there, because while in Old English studies, we've now given up transcribing win with anything other than W. If you work on the transitional period, as I often do, actually you really do want to keep win and W apart, because then you're able to track the gradual introduction into English of W. So all of this is to say that the existing QWERTY keyboard is really inadequate to represent the kinds of graphemic variation you find in Old English. And so this is why we got interested in wondering if there was a better way to do this. And the biggest challenge with this really was trying to derive the inventory that we wanted to transcribe in tandem with actually preparing the training data, so that there isn't any list of the graphemes one should represent in Old English. So we actually had to work them out as we were going along. Two people have been key to this endeavor. One is Peter Baker, who developed Unicode, a font some of you may know, and who has been very receptive to our ideas that he should add hundreds of symbols to Unicode so that we can represent them from manuscripts. So we're very grateful to Peter for that. And second is Taryn Wills, who is the person on the left in this wonderful image, who is the current chair of the Medieval Unicode Font Initiative, or MUFI, which basically maintains a database of unusual characters you might want to represent when editing medieval texts, and has been very helpful in setting up a project page for Ansund there that gives our full character set, which ensures that anyone can kind of see what we're doing at any given moment. The way we went about identifying the character set was initially we reviewed major paleographical handbooks and tools, so Kerr's Catalogue and Digipal. Then in the summer of last year, we did some pilot work with Noah Schmelly, who is a Trinity undergraduate. We're looking at 4-page samples of as many manuscripts as we could to find new characters, and Noah's actually here in the audience, which is great. And then in this summer, we had research assistants preparing training samples of 30 pages from each of our 24 manuscripts and recording any letter forms that they encountered and hadn't seen before in a spreadsheet, which we've illustrated here, which we then reviewed and made concrete proposals to Taryn and Peter of what new glyphs we needed to be entered into Unicode. So this contains an image of the particular letter form, a description of our usage of it, and suggested MUFI and Unicode names. And then Taryn designed the pipeline to automatically uplift all of this information into MUFI. We've currently proposed 275 new letter forms to Peter, which he's nearly finished making for us. Should have done by the end of this week, hopefully. And as an example, here is the part of the character set for S. So we've got 20 separate forms of S that we think we can distinguish in the training data. And the current character set for Ansund as a whole is about 500. So before you get worrying about this and whether this corpus will actually be usable to anyone but cranks like me and Ellie, we envisage there being 2 flavors at least of Ansund. So one is a kind of full version of the corpus that has the full range of glyphs, the abbreviations unexpanded, and the manuscript word division preserved. And then there'll be a light version, which essentially manually transforms this into a basic QWERTY character set with the abbreviations expanded, the accents removed, that will be tokenized as opposed to having manuscript word division, and may have modern punctuation. And hopefully too, there'll be a lemmatized and part of speech tagged version of this corpus too. So we now want to tell you about our first pilot we did this summer, which we trained for a conference on machine vision called ICDAR, which Ellie will tell you about now.
And I think you can move to the next slide. Yes, thank you. So the model that we trained in this pilot phase, which we renamed ICDAR from after the IT conference where this was presented last summer, was built on a subset of 7 manuscripts, which are the ones that you see here highlighted in green, selected from a larger corpus of 25. And the training data on which this model was built was prepared and fine-tuned with the help of a number of research assistants, some of which are in the audience today, to which we are very grateful. Next, please. Here you can see the variety of scripts and hands on which the model has been trained. And the way that we conceived this was to include, or to try to include where possible, 3 examples from each third of century, from the 10th up to the 12th century, to ensure maximum representation of the widest possible variety of scripts and hands. Next, please. And the training process returned very good results, achieving an accuracy level of 98% or slightly higher, in fact, with an overall character error rate of just 2%, meaning that I think if I'm doing right calculations, only a couple of words or a couple of graphs or films for each 100 were mistranscribed by the machine. Next. And here we can show you how this model works and the results that this gives. So this is a video, and I think you should explain that.
This is a leaf that the model had never seen before and is seeing for the first time and having a go at transcribing.
Next, please.
Oops, it's just playing it again, sorry.
Yeah.
Yeah, here you go.
Yeah, I think you can keep playing while I talk because like we have, yeah, exactly. So as we can see, the model is pretty good. So for example, we can see in the red boxes that it has been able to detect 3 different shapes of Y's, on which we will return later on. And it has also been able to recognize those placeholders that we had to use at that stage of the pilot when we didn't have glyphs for all of the characters that we were looking at. But on the other hand, we can see our line 19, how that Z has been completely mistranscribed as a G, because of course it's a very rare letter in Old English and we didn't have many examples in our training data set. But overall, I think that everyone can agree this is good, right? Next, please.
Yeah, so now we want to try and showcase some of the potential we think that Ansund has. So talking first of all about some of the things that we can see even in our training data, and then talking about how we can move very quickly from our training data to augmenting it by running the model on manuscripts it's never seen and using the data from those manuscripts. So we wanted first of all to see if we could put our training data into some basic Corpus software, and so with a bit of help from Lawrence Anthony, who designed AntConc, we got our extraordinarily rich character set working in AntConc, so that you can actually search within an environment that is familiar to you if you use AntConc or some other Corpus software. And just very basically, to start small and we'll move bigger, here are all of the accents in the acute accents in Corpus Christi College 188 Article 23. So this is part of our training data, and so this just tabulates which letters have accents over them in this item and compares that to the number of occurrences of that letter in the same item. This is very valuable because there's very little quantitative data available for the use of accents in Old English. There's only one study known to me, which is based on 2 manuscripts. So Corpus will very rapidly enable us to scale this up. And just as very brief minor things to notice here, accents occur primarily over vowels. Well, that's probably what we'd expect, but they do also occur over consonants with some regularity. Accents occur much more frequently than you would predict over some letters than others. So they're 5 times more frequent over I than Y, for instance, and never occur over capital letters, at least in this item, which is quite striking. Moving on to a slightly different feature that our transcripts record in Article 23 of Corpus Christi College Cambridge 188, looking at shapes of S. So there's 188 S's in this item in total, and 4 shapes of S. Keyboard capital S, as it were, 3 line S, which is the second one that occurs twice. So where it both ascends above the minimum height and descends below the baseline, low S and long S. And if you look at where these occur in individual words, you see that initially there's more or less free variation between low S and high S, low S and long S, but medially and finally there's a strong preference for low S. And finally, indeed, the only exception to the rule that you use low s as a Latin word rather than an Old English word. When you look at the initial position, actually, there are some quite sophisticated rules being deployed by this scribe when you look at what letters are adjacent to that S. So before a minim height letter, low s is categorical. Before a descender, long S is categorical, and there's very few exceptions to that. And with Y, interestingly, the scribe uses low S before straight-limbed Y and long S before rounded Y. So this is a scribe who has a very sophisticated sense of what form of S to use in what context. And our sense is that this is a kind of fingerprint, that if you were to find any other scribe following this rule for the distribution of S, then you would be quite justified to assume they were working in the same scriptorium. So that's some small data from individual items. Here's some larger data from the training set. And Ellie, I think are going to try and talk about these graphs together.
Yeah.
So this is all of the instances of Y in our full training data. So this is 15,500 Ys organized in chronological order by the date of the manuscript from Hatton 20 to Hatton 38. So from about 895 to 1200. And I suppose the point we'd make about this is that in the early period, there's a lot of variability in terms of shapes of Y, that individual manuscripts have multiple shapes of Y, and that then homogeneity reigns from about 1000 onwards. And then there's some outlying manuscripts in the 12th century that start to show more shapes of Y again. One of which is Cotton Vitellius A15, which has a copy of the soliloquies, which may well be imitating paleographical features of a Alfredian era exemplar. So this is do you want to jump in with this one?
No, go ahead.
This is a representation, essentially the same data, but aggregating the manuscripts by date of production, and very clearly making that point that there's a lot of heterogeneity in the late 9th century and the 10th century, but much more homogeneity in the 11th, and then some variability again emerging in the 12th. You surely have to talk about this one.
Yes, I mean, that's fascinating. What we see here is basically a trend curve in the use of the very different shapes. And what's interesting, beyond the fact that obviously a straight-limbed Y has a peak at the end of the 11th century, starting with the 12th, it starts then decreasing together with all the other shapes. Yes, now obviously we have to keep in mind when we look at this that we have some imbalances in our data set in terms of manuscript representation, and normalization, that's what I meant. But it's interesting, and I think that Mark, you may want to move to the next slide, that we see this curve all of a sudden decreasing towards the end of the 12th century. See how it goes down there.
Who works on the 12th century to see the overall use of Y decreasing in the 12th century manuscripts. So I went to the Linguistic Atlas of Early Medieval English to see if this is corroborated in 13th century data. And so what this is the ratio of I to Y in all the manuscripts in Lamy. So based on 238,000 or so I's and Y's, and it's essentially showing that the ratio of I to Y increases in the between 1150 and 1250. So they're using more I's than Y's, in some cases actually 500 times more. This is put on a log scale because the representation in a normal scale, it just doesn't work. And then you rapidly get an increase in Y again after 1225 or so. And that's probably because Thorn is increasingly being written Y in late Middle English. And to compare this to the Old English data, that X around 1150 is the approximate place that the Old English data would fall for the that we have. So what these graphs between them show is the sort of longue durée fortune of an individual pair of letters, which I think is rather amazing and not something we've hitherto been able to do before, to look at how two letters fared over a period of about 500 years. We also looked at dotting of Y. So whether scribes were consistently dotting their shapes of Y. So this is irrespective of what shape of Y they use, whether they dot it or don't dot it. So in light, you have light blue, you have the undotted forms. In dark blue, you have the dotted forms. And you can see, again, the manuscript's organized in chronological order. So you can see that undotting is the norm in the 9th century and most of the 10th, but gives way to dotting from the 11th, where it's almost categorical, and then you get some undotted forms again in the 12th. So the 11th century is really emerging as a period of great homogeneity in these graphs. This takes that data and again aggregates the manuscripts that have the same date. So very clearly shows the point we were making. And then this likewise shows the trend line. So undotting the norm in the 9th and 10th centuries, dotting the norm in the 11th, and a period of transition again in the 12th back to undotting.
I think that's very interesting because that's technically called an inverse trend line. So you can see that you have simultaneously one of the lines that goes up, whereas the others goes down. And I think it's interesting what happens here in the mid-12th century where they have a contact point before diverging again. And I think that this kind of graph shows this very clearly in ways that, the stacked bar that we had before doesn't. So this clearly displays the sort of evolution in the distribution over time of both forms.
Great. So all of that hitherto has been based on our training data, so has actually been seen by a research assistant and in some cases checked by us. What we're going to talk about now is, if I can make the slide behave, is looking at augmenting that data by running the model we trained for ICDAR on stuff it's never seen before, and thus generating data that's entirely created by machine learning. So here we this is based initially on the training data that we prepared for the Exeter book. So this is actually stuff that the research assistants have seen and has been human verified, but we're giving this now to compare it to the information we're going to give in a moment, which comes from manuscripts that no human has looked at, or at least not in the context of our work has looked at. That sounded very exciting, sorry. So here, these are the different shapes of Y that you get in the Exeter book. We have 68 pages from the Exeter book in our training data, so that's just over 1,000 Ys, and there are 5 different shapes used. So straight-limbed Y, F-shaped Y, rounded Y, and rounded Y that descends below the minimum line, descends below the baseline rather. And this is looking at what position in a word these different shapes of Y occur in. So F-shaped Y and rounded Y are ostensibly in more or less free variation, medially and finally. But there's a strong an avoidance of straight-limbed Y initially.
And it's interesting, Mark, that when it's found in initial position, this straight-limbed Y is dotted, whereas in all the other cases it's not. That's the only instance where we have a strong, like 82% of this is dotted. So.
Yeah. Yes. And then this is looking at what letters occur before and after the Ys. So in the graph to the left is where a C occurs before a Y, and then you can see what kinds of shapes of Y occur after that letter. So here it's F-shaped Y that predominates after C, whereas as you can see for H, which has an ascender, there's more of a prevalent, there's at least a significantly larger proportion of straight-limbed Y where an H precedes it. And then on the right, you have looking at the character following the Y. So, for instance, with following N it's again F-shaped Y that predominates, but there's some rounded Y and some straight-limbed Y. Now, the exciting bit. Let's run this on a manuscript our model has never seen before. So we took 30 pages from Corpus Christi College, Oxford 197, the bilingual manuscript of the Rule of St. Benedict, just the English bits, not the Latin, and got 372 Ys from that, which are distributed as follows. So there's 6 different forms being used if you count dotting and undotting as separate forms.
Yeah.
And again, looking at the word position as what kinds of patterns there are. So there's 2 main shapes of Y, rounded and straight-limbed, that are more or less in free variation. Rounded and straight-limbed, and then a few other forms found as well.
And again, it's interesting that there is no use of F-shaped Y in the graph.
Yeah, so no F-shaped Y in Corpus 197. And then this is the characters which precede the Y and follow the Y. Again, so you hopefully know how to read these kind of graphs by now. And then most interestingly of all, comparing the Exeter and Corpus 197 on the basis of what their preference is before different types of letters. So we took 3 very frequent letters. We took H, which is an ascender, low S, which is a descender, and C, which is a minim height letter, and looked at how the different shapes of Y were distributed before and after them. Or sorry, in this case, just preceding that Y. So with H, the distribution is very similar between the Exeter book and Corpus 197. With low S, the distribution is quite different, and with C, it's also quite different how which form of Y is used after C in the 2 manuscripts. And this is looking at. Sorry, you go on.
No. Go ahead, sir.
And this is characters following the Y. So when an L follows the Y, and when an R follows the Y, and when an N follows the Y. And again, this is effectively, we would say, a kind of fingerprinting where you can compare the way in which scribes are copying text in very minute details, and you could imagine multiplying this up for different combinations of letters and using methods like cluster analysis to compare how the scribes are writing. Was there anything you wanted
to add? Yes, all I wanted to add is that those percentages have been calculated through normalization, which means that what you see here has been calculated taking into account the fact that in the Corpus manuscript we have some 370 shapes, whereas in the Exeter book we have 1,000. So those percentages, they take this into account. So they are proportional. That's important, I think, to point out.
Yeah, thanks, Sally. So we've been enthusing a lot about the paleographical possibilities of Ansund, but we'd also like to emphasize that the interest of this is linguistic too, that Corpus Christi College Oxford 197 is not available in the Dictionary of Old English corpus. It has a number of texts of the Benedictine rule in Old English from different manuscripts, but not the one from Corpus Christi College Oxford 197. And so HTR is here making available a text for linguistic investigation that's hitherto not been available, and that very much reflects the potential of Ansund in total, because a significant number of manuscripts that survive are very underrepresented in the Dictionary of Old English corpus, like Cotton Fastina A9 at the bottom there. So we have a number of problems still, which are therefore outstanding, and perhaps outstanding in another sense too. One of which is to do with word division, which Ellie is going to tell you about.
Thank you. That's my favorite problem, as I've said many times before. And obviously, we all know that the word division that we currently find in editions does not reflect the one that we see in the manuscripts. And this has, of course, been something that we had to take into account in the training stage of the model. So we originally thought that we could mirror what we saw in the manuscripts, but very suddenly realized that it was actually very ambiguous at places where you couldn't make an objective decision. And so we eventually opted for the standardized form of that. However, one of the goals of our project is to be able to represent word division as is on the manuscript. And that's very challenging for the types of scripts that we have. But we're currently working on that. And one of the approaches that we have taken is to identify through a series of algorithms the leftmost and rightmost points for each character, and then calculate the vectorial distances between those, and thus returning the distance expressed in pixel terms. That's very complex, and that requires a lot of maths behind it, but I think we are getting there. And another approach that we have been attempting is to use boxes, so which is the one that you see in the third image here. So to identify boxes around each character and then compute the distance between those, but I think that this is a less effective way. So that's all ongoing, and that's, I think, all very fascinating, especially if you think about the results that this could bring.
Because obviously we're in a period where word division is actually emerging as a feature of written English. So to have accurate data about word spacing would be really fascinating. Another of our problems is to do with stratigraphy, so the different layers of annotation that are often found on many a manuscript page. So this is from Hatton 116, which is in our training data, where the tremulous hand has had his way with the original text in numerous ways, with additions to punctuation in terms of that colon after bacumen, also glossing and adding line end hyphens. So we're ignoring all later additions in this training phase because it's what's better for the machine in our view. But we do want to develop some protocols for including this material in the eventual release of Ansund, and to what extent we can do that via HTR is something we still need to explore. And then a third sort of problem concerns the design of the eventual corpus, and how we might facilitate reference between different copies of the same work. In existing published scholarship, ground truth is usually an addition. So if people are working on Elfrich's Catholic Homilies and a particular manuscript of it, like Corpus 198, they'll say, well, this is Clemo's page 36, line 2. We prefer not to refer to an addition for, firstly, copyright reasons, and secondly, that edition may become obsolete in the life cycle of Ansund. And so we want some other kind of system of intertextual reference to be able to say that page 237, line 11 in this manuscript has the same text as page 36, line 2 of this other manuscript. Ideally, this would not involve picking a base text, because that encodes certain ideological assumptions about the base text being better and the other text being worse or deficient in some way. So there's a sort of philosophical cognitive problem here that we need to get our heads around too. So our next steps, other than a big drink after finishing the paper, we want to train the full model. So we've been presenting work based on the model we trained for ICDAR, which is a 250-page subset of a set of training data that totals 920 pages. That 920-page set of training data has 3 manuscripts per sub-period as opposed to 1, and includes Hatton 20, which Ariana, who's here, worked on for hours and hours, and is one of the most nightmarish things in the world, but also very interesting because it contains numerous letter forms that just are not found in any of the other manuscripts. We're hosting a colloquium in Trinity on the 29th of November, where we'll present the full pilots for the project and have an afternoon's discussion of the next steps, including the funding strategy, the kind of business model for Ansund, looking to get buy-in from the libraries who hold the manuscripts, because we estimate that maybe only 60 to 70% of manuscripts containing Old English have been digitized to this point. So the remaining ones will require digitization if we're to use HTR on them, and to survey user requirements. And just a little plug for Trinity 2, that colloquium will be preceded by Elaine Trahan's Kemble lecture on Mundane Matters, Early English Manuscripts 700 to 1200 and the Aesthetics of the Ordinary the night before. So there's lots of reasons to come to Dublin in late November. The business model, research funding from various bodies certainly, and one of the reasons for wanting to present at ISSEME on this is that there's a world in which we build in a crowdfunding element, a crowdsourced element to this in terms of correcting the output of the model. As Ellie said, our pilot makes one mistake every 50 letters, which is pretty good. It's intellectually an open question whether we should even correct that, or whether one character being wrong in 50 letters is adequate for some purposes at least. But if we decide it should be corrected, then it's possible that we might look to build a way in which the community can contribute to the correction of this corpus. Future steps. So those were next steps, and these are future steps. So this is where we dream. You should talk about this.
Yes, obviously I should, shouldn't I? This is what we technically call a confusion matrix, which has been generated using the training data for the Exhaustive book. How does this work? Well, we are not quite sure, to be fair, but I think that the way this works is that it crosses the ground truth, so the transcriptions that we have used as an input for the machine, and the predicted outcomes of this. And through this cross-checking, you can see what characters have been transcribed with more or less confidence by the machine. So obviously the matrix is quite big given the number of glyphs that are involved in this. And in more detail here, I think that we're looking at, Mark, correct me if I'm wrong, I think that we're looking at the characters that have been transcribed wrongly, right? I think so, or more wrongly than others. I think that's the function of that. Anyway, regardless, the confusion matrix is just a tool that we have to evaluate the performance of the model and to see where it is more weak, so as to be able to fine-tune that on the basis of the glyphs that have been less well identified and transcribed.
Yeah, so all of this is really part of a degree of reflexivity on our part about our character set.
Yes.
And because we don't, what this will enable us to identify is where the machine is incapable of making distinctions that we want to try and make. And if the machine is incapable of distinguishing some of the characters we want to distinguish, we probably shouldn't try and distinguish them. And maybe it's also evidence that they're not really distinct and it's just us hallucinating, which is very possible after a day spent looking at Hatton 20. So this is part of a process of reflexivity about the character set that we'd hope to go through once we've completed the full pilot. Another way we can do this is we can look at its performance on unseen material. So these are the least confident predictions for those 5 pages of the Benedictine rule that we ran the model over. And so it was least confident of all about the H in Elmichtigne there. In fact, it was right about it, but it would only thought it was a 50% chance that it was right about that. It thought it had a chance to be 58% right about the T in Petcha. So it did in fact get something wrong in that word, but it wasn't the T. But you can also see maybe why it did get something wrong, because the T and that ash are very closely written. In Folger, it mistook a punctus versus for Turonian nota. And you can then also see that a lot of these mistakes are in 3 verso / 15, where you've got some bleed through from the other side of the leaf that essentially meant it had a really tough time reading it. The reason we were interested in looking at this is one of the problems we're going to face is identifying unseen glyphs. So there are going to be letter shapes in manuscripts that we're not having human sight of, and we need a way to find those. And our hypothesis was that the letters that the machine was least confident in its transcription of could putatively be unseen characters. That doesn't seem to have quite worked here, but we will explore this some more. Certainly, it seems a good way of identifying places where the machine has had a really tough time. Like this list clearly shows that 3 verso 15 was difficult for it. You want to talk about this?
And that's the box plot from which the data that we have just seen in the previous slide was taken. And this shows basically how confident, again, the model has been in transcribing those two folios from the Corpus manuscripts. Now, what's interesting is that you see the first point here, just in the lower side of the graph, the H. This is the one that in the previous slide we have seen being the less confident character. And now what's interesting is that those small circles that indicate like random instances of specific letters being not correctly read. So actually you should be looking at the blue bit. That's where the confidence lies. However, there are instances which are represented by those circles in which the model basically is not so sure about what's being predicted. So regardless, I would say that we have a pretty good confidence except for the letter H here. But in general, I think it's not bad at all, given that we have a median that is above 0.9. So, and again, we're running this on just a couple of folios. So that's from it, that means very partial. We should have, this for the whole manuscript to have much better idea. But I think it's a very useful tool. And again, it gives you a way of measuring things that you couldn't do otherwise. Most important there.
Scaling up would be trivial, is the point. The hard bit is coding one of these, and then you could easily scale up to the whole manuscript.
Yeah.
I've already mentioned that Taryn and Wills is one of our collaborators from MUFI, and we had a Zoom call with Taryn last week and mentioned an idea we had, and then he stayed up till 4 a.m. coding and produced proof of concept for it. So this essentially extracts all of the individual letter forms from a manuscript page. It's not Old English, it's a Latin manuscript, and it extracts all of the letter forms along with the predictions. This is coded in Kraken, which is one of the reasons we mentioned Kraken at the beginning. And then it can aggregate those captures into illustrating every single form of a given letter within your data. So there at the bottom, you have all of the Fs in this particular sample of Latin. And so that actually gives you the possibility to look at all of these Fs and decide if you're happy with having transcribed them all as F, or if there's actually some slightly different transcription you want to use for some of them. And to show that even that task can be abstracted, here's a little bit of work by a PhD student called Colin Bresson, who works on Chinese and was looking at different letter shapes of the character ding. So this is a plot in PCA space. So there's no real scale to this graph, but things that are close together are more similar than others. And so you could use these kind of PCA plots to check that you are indeed distinguishing the main subtypes of a particular letter. So ideally, our character set would be visible as particular zones in a PCA plot. And that would validate our decisions at this stage, or it would challenge them, and then we can review them. We also want to pilot the pipeline for digitization and for working with the libraries, and we've just put in an application to do some work on Old English manuscripts in Rouen, including this one, which is a continental manuscript of Bede's De Temporum Ratione, but has a 12th century note taken from the Old English Erosius, probably copied by a continental scribe. We'll hopefully use this work with Rouen to pilot working with libraries in the UK and elsewhere as to how we actually make sure that the remaining Old English that hasn't been digitized gets digitized. And we've got representatives of Cambridge, Oxford and the British Library coming to the colloquium for precisely this reason. So that's it from us. If you've got thoughts or feedback, you can air them in the questions, or you can email us, ideally both of us simultaneously.
Thank you very much, Mark and Elisabetta. It's amazing to see all the work that you're doing. And I mean, the machine learning is impressive, but the human learning on display was also very much impressive. So thank you for that. I'm going to stop the recording and then we'll start the Q&A.